Before we get into HyperExtract, quick context for this setup. The workflow I am using is fully local, works with the current coding agent stack, and can hand work across codecs, Claude Code, Gemini, OpenCode, Quinn Code, Copilot, Cursor Agent, and other agents through Conductor OSS. You can see it at conductoros.com. Now the actual source today is Hassan Tour's post about HyperExtract, a repo that claims one command can turn messy documents into structured knowledge instead of loose chunks. The post is image only, so there is no demo video or human narration to preserve. The useful proof is the tweet text, the GitHub repository, the official docs, the package metadata, and a local CLI smoke check. Hassan's claim is specific. HyperExtract turns unstructured text into knowledge graphs, hypergraphs, temporal graphs, spatial graphs, spatiotemporal graphs, strongly typed data models, Obsidian vaults, and MCP-ready knowledge bases. That is a big claim, but it is not just marketing text. The README describes the same goal using the term knowledge abstracts, and the docs show a terminal-first workflow built around the he command. Here is the simple way to understand it. Normal RAG often starts by slicing a document into chunks, embedding those chunks, and hoping retrieval pulls back the right paragraph later. HyperExtract is trying to move one level earlier. It asks the model to produce a typed structure first, then keeps that structure as the artifact you search, visualize, feed, export, or query. The README says the project supports 8 autotypes, including models, lists, sets, graphs, hypergraphs, temporal graphs, spatial graphs, and spatiotemporal graphs. That matters because a contract, an earnings call, a research paper, and a field report are not the same shape of knowledge. The quick start is straightforward. Install the package with UV tool, install HyperExtract, configure a provider, then run he parse against a document with a template like general biography graph. After that, he show opens the visualization, he search runs semantic search, he talk lets you ask questions against the extracted knowledge, and he feed can add new documents without starting over. I also verified the published CLI locally with UVX. The command list includes parse, show, info, search, talk, feed, build index, clean, list, config, and export. That is the part that makes this feel more like a knowledge workflow than a one-off parser. The strongest visual proof is the output model. The official screenshots show a document moving through AI processing into lists, sets, graphs, hypergraphs, and timelines. The graph visualization example uses Nikola Tesla, with visible nodes, edges, and a details panel. The docs call out a 3-layer architecture. Autotypes define the output structure, methods provide the extraction algorithms, and templates package domain-specific defaults. The README also lists more than 10 extraction engines, including GraphRAG, LightRAG, HyperRAG, KGGen, and related methods. So the repo is not saying every document gets the same graph. It is saying the output shape is selectable. The practical angle is the template library. HyperExtract advertises more than 80 YAML templates across finance, legal, medical, traditional Chinese medicine, industry, and general domains. That is why Hassan's examples make sense. You could parse a research paper into a concept graph, pull companies, people, metrics, and risks from an earnings report, or build a private searchable knowledge base from internal documents. Version 0.3 also added the newer workflow pieces that matter for agents: Claude model support, Obsidian export, a clean command, and an MCP server. The MCP docs say the server is read and export only, which is exactly the safer posture you want when an IDE agent queries your knowledge base. There are caveats. This is not magic document understanding, and it is not a replacement for checking extraction quality. It depends on structured output behavior from the selected model, plus an embedder for search. The docs explicitly say Anthropic can be used as the LLM, but because Anthropic has no embedding API, you pair it with an OpenAI-compatible embedder. Local VLLM is also supported, with an example using Qwen and BGE-M3, but you still need the local model stack running. The repo metadata and PyPI package currently show version 0.3, Python 3.11 or newer, and Apache 2.0 licensing in the project files. Treat it as promising infrastructure, not a finished oracle. My take is this. HyperExtract is interesting because it gives agent workflows a cleaner memory substrate. Instead of asking an agent to reread messy PDFs forever, you can pre-shape the documents into graphs, typed objects, Obsidian notes, and MCP queryable knowledge. The repo link is in the description. And if you want to run coding agents around systems like this locally, the same setup works with all coding agents in the current stack through Conductor OSS, fully local, at conductros.com. With the GitHub repo at github.com/sharonik06/conductoross.